Okay, we're reviewing our homework. Which statement best describes a concentrated solution? Is it a solution that has very little solute? Is it one that has great amount of solute? It's considered watered down or has a low molarity. So if we're talking about concentrated, that would be B and has a great amount of solute dissolved in solvent. Which statement best describes a dilute, which is going to be the opposite of our concentrated? It says check all that apply. Hint, there are 3. Is this solution that has very little solute? Yes. It's not a great amount. We learned that in the last one. That's concentrated. It can be watered down or it has a low molarity. So it would be the 3 out of those 4. It looks like I put number 2 in here twice, so I'm going to get rid of that. Using the image below, which of the glasses is the most concentrated solution? We're going to see if we're looking at concentration, aka color, we're going to see that it's going to be the first one. So this one would be our concentrated one, this one would be our dilute one. I made lemonade. When I took a sip of it, it was way too strong because it was blank, and I added water to it so it would become more blank. So we would see that it was concentrated because it had a great amount of solute dissolved in it. And when I added water, I diluted it. If you add a spoonful of sugar to a glass of water and it dissolves, so it forms a solution, which is the solvent. Well, if we're thinking about we have a glass of water and we have a spoonful of sugar, we're going to see our sugar would represent our solute, and then what we're dissolving it in, our dissolving medium, would be our solvent. So the water would be the solvent. So number 6, what would be the solute? That would be our sugar. Now, what is the formula for molarity? So remember, molarity is big M, so we can get rid of our ideal gas law and Boyle's. So molarity equals mole over liter, because we see that molarity, so we have our mole first and our larity, aka our liters, second. Now match the correct variable with the correct unit. Molarity is going to be big M, aka moles over liter. The amount of solute is our number of moles, and the volume of our solution is going to be our liters for it. Okay, number 9. What is the molarity of solution that has 1.2 liters and 0.25 moles? So remember, molarity is our moles, so that's 0.25 mol over 1.2 liters. So 0.25 divided by 1.2, we get a very long decimal. We get 208,333,333 repeating. So we see they have 2 sig figs, count over 1, 2, we'll 8 round it up. Yes, so we'll see that it's 0.21. What's the correct formula for a dilution? So this one was molarity. This is the ideal gas law, and this is the y equals mx plus b, the slope of a line. So we're going to see dilution is when we have our concentrated and we are diluting it to the other one. Number 11, how many milliliters of 15 molar, so we have our V1 and our M1, must be diluted to prepare 25 milliliters, that's our volume 2, for 6.5, our molarity 2. So if we set it up in our M1, V1, M2, V2, we see that we have 15M, we don't know our volume, and we have 6.5, and we have 25. So if we multiply this side, we have 15x, then we multiply 6.5 times 25, and we get 162.5. So now solve out for x, divide both sides by 15. So 162.5 divided by 15 gives us 10.83333 repeating. Go back to the problem. It lets us know that they all have 2 sig figs, so go over. We'll 8 round 0 up. Yes, so we'll have letter choice C, which is 11 milliliters. So what does this mean? Well, if we had to make 25 milliliters total, 11 of it would be from our concentrated 15 molar, and then 25 minus 11 would give us 14 milliliters of water to dilute this solution. So this takes us through our homework on molarity, solution vocab, and dilution.